Hi everyone, welcome to our second video for week 2. Today we're going to be talking about independent and mutually exclusive events. We'll start with independent events. If two events are independent, the knowledge that one occurred does not affect the chances of the other occurring. A really common example, if we're flipping a coin repeatedly, knowing that heads resulted from the first flip doesn't tell me what's going to happen on the second. Could be heads, could be tails. Each flip is independent of the others. And another example, rolling two fair six-sided dice. The outcomes are independent because the outcome of the first die does not affect the outcome of the second. Knowing that the first die landed on 1 doesn't tell me anything about what the second die landed on. To show that two events are independent, you must show that one of the following are true. You can show that the probability of A given B is just the probability of A by itself. You can show that the probability of B given A is just the probability of B by itself. Or you can show that the probability of A and B happening is equal to PA times PB. If you check for independence and you find that it fails one of these conditions, that tells us the two events are not independent, and in that case we call them dependent. So events can be categorized as independent or dependent. You're going to see two new vocab phrases. Sampling may be done with replacement or without replacement. And those key phrases are important because they tell us whether our events are independent or dependent. If we sample with replacement, each time we pull someone from the population, we put it back after it's selected so that it can be selected again. This produces independent events because with each draw, we're pulling from the exact same population with the exact same probabilities. Without replacement means once we pull somebody from the population, they're not put back. We can only pull them once. This results in dependent events. If I remove someone from the population, the next time I go to select, I'm pulling from a smaller group. So the probabilities will be different. If you don't know whether A and B are independent or dependent, you should assume they are dependent until you can show otherwise. And we know to show otherwise, we have to use one of those 3 checks from the last slide. So let's really quick do an example. We have a bag with 3 red marbles, 2 green marbles, and 4 blue marbles, and we're going to use this information to answer the questions below. First, 3 plus 2 is 5 plus 4 is 9. So we know initially this bag has 9 marbles in it. And number 1 says if we draw with replacement, what is the probability of drawing a red given that we drew a blue on the first draw? So with replacement means I drew a blue, I recorded on a sheet of paper that I drew a blue, and then I put that blue marble back into the bag before I drew the red. So that means the number of red marbles in the bag has not been affected, and the total number of marbles in the bag has not been affected. These are independent draws. So there are 3 red marbles in the bag, 9 total marbles in the bag. Our probability is 3/9. For the second one, if we draw without replacement, what is the probability of drawing a green given we drew a green on the first draw? Without replacement means I draw a green on the first draw and I hang on to it. I don't put it back in the bag. So when I go to draw that second green, there's now a different number of marbles in the bag. So the probability of drawing that second green is the number of green marbles left divided by the total marbles left. Well, I had 2 greens to start with and I've removed 1, so I only have 1 green left. There were 9 total marbles and I removed 1, so now I only have 8 marbles left. So the probability of getting a green on the second draw, given that the first one was green, should be 1 out of 8. For the last one, it says if we draw without replacement, what is the probability of drawing a green on the third draw, given the first 2 marbles were green? Without replacement, again, means we're taking them out and keeping them. They don't go back in the bag. So the idea is similar. Green marbles left divided by total marbles left. Well, we drew 2 green marbles from the bag, and I only had 2 to begin with. So I have no green marbles left. For the denominator, total marbles left, I started with 9. I removed 2. I should be left with 7. So there are 0 green marbles left out of 7 total marbles. So the probability of drawing a green on the third draw, if the first 2 were green, is 0, meaning it's not possible. The other thing we need to talk about is mutually exclusive events. So A and B are considered mutually exclusive events if they cannot occur at the same time. So for example, in a standard deck of playing cards, we have 2 colors, red and black. We have 4 suits, clubs, spades, hearts, and diamonds. And then ace, 2 through 10, jack, queen, and king. The red and black are mutually exclusive. You can be a black card, meaning you're a club or a spade. You can be a red card, meaning you're a heart or a diamond. You cannot be both at the same time. So we would say for a standard deck of cards, red and black are mutually exclusive events. If A and B are mutually exclusive, P, A, and B should be 0 because they don't share any outcomes. So if this were the entire deck of cards, A would be red cards, B would be black cards. We know for a fact that there's no cards in the deck that are both red and black at the same time, so there's no overlap between those 2 groups. So A and B is 0. So notice again, that overlap we saw in our last video is not present here because those 2 events, red and black, don't have anything in common. Interesting question. Are mutually exclusive events dependent or independent? And why? So I want you to think about that, and we will talk about that in a later video. All right, if you have any questions, please contact me via email or text message. Contact info is on Canvas. I also have office hours Tuesday, Thursday, noon to 1 and 7 to 8. I'll see you in the next video.